You are now tuned into the network, the YouTube channel that takes complex networking topics and dumbs it down to a more simpler language. And today's topic is next generation firewalls and IPS. No, we're not talking about beer. We want to explain the role of network components, and these are the two type of network components that we're going to discuss today. Let's go ahead and take a look at the exam blueprint to see where we came from and where we're headed. All right, so this is the exam blueprint, CCNA exam version 1.0. The exam code is 200-301. Make sure you signed up for the correct exam. It's been a minute since we've done a video. In the last video, we actually did our hands-on with layer 2 and layer 3 switches. Today, we are going to do the theory of next generation firewalls and IPS. Again, this is section 1.1c, and we only need to explain the role and functions of these two components. But remember, next video, we're going to get our hands dirty as well. So what is a next generation firewall in IPS? Well, basically, a firewall is a device that that protects your network. In short, it's just a device that sits usually on the outside of your network and protects any kind of, because you know there's all kind of threats that are out in the internet and stuff like that, right? Let's go ahead and take a look at the official definition though. What is a firewall? In computing, a firewall is a network security system that monitors and controls incoming and outgoing network traffic based on predetermined security rules. Firewall typically establishes a barrier between a trusted network and an untrusted network, such as the internet. So now if you look at this this little image right here, we got this little brick wall right here. Usually if you're looking at a network topology or a network map, you're going to have a brick wall that basically indicates a firewall, right? So if you notice, the firewall sits between our PC right here and this globe right here, right? Which indicates the internet, right? And the internet is known as what? The WWW, right? I know most of y'all know that as what? World Wide Web, right? Well, I like to refer to it as the Wild Wild West, because anything goes out in the internet, right? You have all kinds of threats that are out there. Malware, torrenting, hackers, all kinds of stuff that's happening out in the internet. So we need something that's going to protect us over here on our local area network, LAN, right? And we have the internet right out here. So the device that's going to protect us, basically, obviously, is the firewall right over here, right? Simply put, when you look at this, this is exactly what our network topology, you know, we're going to get a little deeper into this, but this is exactly what it is. We just have something that's protecting us from the World Wide Web, or the Wild Wild West is what I like to refer to as. Now, what does a firewall do? We have several functions that a firewall does, right? Now, there's all kind of brands. Now, y'all know on my channel, I focus mostly on Cisco products, but there's all kind of other firewalls that are out there. You know, you've got Juniper. You've also got Palo Alto is another popular brand that they use for firewalls. But, you know, for this channel, obviously this is for the Cisco CCNA exam. We're going to discuss Cisco firewalls. But traditionally, most firewalls have these type of functions right here, right? It matches the source and destination IP addresses. So let's say you got a packet coming to this firewall that we have in our topology right here, right? We got traffic that's going outbound, right? So we coming from the local area network, and it's going out here. Now, before it does that, it's going to inspect the packet. It's going to look at the source, where it came from, and then the destination IP address, where it's going to, right? And it'll whether make that decision on whether to allow or block that traffic, right? You would think, okay, why would we want to block traffic that's coming from the inside of our network to the outside of our network? It could be several reasons, right? Maybe we just don't want, you know, let's say if you work at a school, you don't want students to access, you know, Facebook or some kind of web. That's what the firewall will do. It'll look at the source and destination IP addresses, make that decision on whether to allow or block that traffic. Identify applications by matching their static, well-known TCP and UDP ports, right? We haven't talked about protocols like TCP and UDP, right? But, you know, there's also, there's different port numbers that we need to pay attention to, right? Like you also, like Telnet, for example, uses port number 23. NTP, Network Time Protocol, which uses, I believe, port 123, quote me on that. That's our quiz for today. I believe that's what it is. What is the port number for NTP, right? So all these protocols have different port numbers. The firewall will use those port numbers to make that decision on whether to allow or deny that traffic going inbound or outbound. That's what the firewall will do, right? It will watch application layer flows to know what additional ports are being used by a particular flow. Basically, makes that decision by looking at port numbers and applications, etc. Right? Match the text and the URI of a HTTP request. So if you know what an HTTP GET is, like when you're going on the internet, you know, you have it makes a request on different web servers. It'll look at those requests and whether it makes that decision on whether to allow or deny the traffic, inbound or outbound, right? It keeps stateful information by storing information about each packet and make decisions about filtering future packets, blah, 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 blah. Now, I don't even know why I put this long ass definition there. I want to talk about what a stateful firewall is and a stateless firewall is, right? We'll talk about that in the next slide, but first I want to bring y'all to this analogy of what of a firewall, right? So the difference between a stateless and a stateful firewall. Now, any of my OG subscribers, y'all remember this little image right here. I use this analogy to explain what an ACL does, right? An access control list, right? Now I messed that up right there. Anyway, so a firewall can be compared to a bouncer at a nightclub, right? We got this guy right here who is the bouncer, right? This guy right here with his long ass beard, kind of like mine. And we got all these people right here. This bouncer right here will represent the firewall, as you can see right here. And then we have all these people right here that's trying to get into the nightclub, right? All these people are the packets or information that's flowing in and out of our network. Now, the firewall, he's just going to be standing there. He's going to be patting people down. He's going to be looking at ID cards, right? He's going to be looking at your dress code. You see if you follow the dress code. He's going to look at the RSVP list, etc., right? Before he lets you in or out of the club, right? That's basically what a firewall does. It takes these packets that's coming in and out of the network, inspects them, and makes the decision on whether to allow or deny the traffic. That's basically what it does. Now, what's the difference between stateful versus a stateless firewall? As you can see here, if y'all a fast reader, you can see right here, stateful remembers the state of the packets in the past. So let's take it back to this firewall right here, the bouncer, right? Let's say you and your homegirls or you and your homeboys, right, came to the club, right? The firewall, he basically, you know, he looks at you guys coming in and out, coming into the club, right? He's checking your IDs, he's checking your dress code, right? And then he just lets y'all in, right? Let's say one of y'all, you or your homeboy or whatever, forgot something in the car. Like, let's say he forgot his, I don't know, like his cell phone or something. Like one of your girls forgot her cell phone. She got a TikTok or Instagram the entire night, put it on her storyline, right? So she goes out to her car, right? She comes back to the line, right? And meets up with the firewall again. And the firewall is like, let me see your ID, please. Again. And she's just like, you just saw me in here. Like, you saw me in the nightclub in here like 5 minutes ago. He don't remember that. So therefore, he is a stateless firewall. He does not remember the state of the incoming and outgoing packets. He just checking IDs. He just looking at dress codes. He don't remember your name. He don't remember all of that. He is stateless. That's what the stateless firewall will do. He don't remember all of that, right? So he'll check your information, check your ID card, look at your dress code, and then he'll make that decision. The stateful, you guessed it, remembers the state of the packets in the past. So let's say your homeboy forgot his wallet or whatever, or he forgot something in his car. He wanted to step out the club to go smoke or something. He steps out, comes back to the nightclub, right, and gets to the firewall, and the firewall looks at him and he's like, oh yeah, I remember you. He don't even check his ID. He just remembered, him from coming into the club 10 minutes ago, whatever. That's what the stateful, it remembers the state of the packet coming in and out of that network, and he makes that decision on whether to allow or deny, right? Let's say he didn't even let you in the first time, right? You came in to the nightclub as the packet, right? He gets there and he sees you and your homeboys, and y'all look like knuckleheads, or he remembers y'all was in a fight last time y'all came to this club. He's like, oh, no, I'm not going to let y'all in, right? I'm not going to let y'all in. So therefore, he is a stateful. He remembers the state of y'all from the past. That's what a stateful. That's the difference between stateful versus a stateless firewall. I wish I would have fixed these texts before I made these slides. So now that we discussed what stateful versus stateless firewalls do, let's talk about the security zones, right? Now, this is another concept we need to know about firewalls. A zone is a group of interfaces that have similar functions or features. Zones establish the security borders of a network. So if we look at this topology right here, shout out to networklessons.com. Y'all visit that website. This is Renee Molnar's website. He's got great icons. He's got tutorials all the way from CCNA exam all the way up to the CCIE exam. And he discussed all kinds of topics, firewalls, etc., right? And that's where I got this image from, right? So if you notice right here, we've got an inside network, which is similar to what we said over here. We got our LAN. This would be considered our inside of the network. On this side of the firewall, World Wide Web, right, we would consider that the outside of the network. Now, how do we determine which one is inside or outside on the firewall, right? Well, on the firewall, we do that with the interfaces. So, interface GI00, we would consider this an inside interface, right? We would consider GI01, you guessed it, another inside interface, right? Because this local area network is on the inside of the network. That local area network is on the inside of the network. And then we're going to make these two interfaces consider them outside, right? So those are the two. That's how we determine what the security zones are. Which one's considered an outside facing interface versus an inside facing interface, right? Zones establish the security borders of a network. A zone defines the boundary where traffic is subjected to policy restrictions as it crosses to another region of a network. So you can consider these guys bouncers right here. That interface is a bouncer. That guy's a bouncer. That guy. So basically, we got 4 bouncers, right? This one's going to make a decision on whether to allow or deny. That's going to make a decision on whether to allow or deny, etc. Those guys right here and this guy's right here. So we basically got 4 bouncers. 2 of them are going to be on the outside, and 2 of them are going to be on the inside. They can make those decisions using access control lists and rules that we apply inside the firewall. We'll get our hands dirty in the next video. It might be either an ASA, basic ASA firewall, or we may do something with firepower management if I get my hands on it. It depends. So, a DMZ. What is a DMZ? A DMZ is a demilitarized zone, or DZ, is an area in which treaties or agreements between nations, military powers, or contending groups forbid military installations, activities, or personnel. Basically, we saying in this area, we don't want to have any kind of like guns or any kind of, seize your fire in this area. Now, you might be wondering, why am I on this channel talking about DMZs or geography and stuff like that, right? Well, this is very important when we're talking about network security. DMZ is a term that we use a lot in network security. This is why I wanted to bring this up. I wanted to talk about what a DMZ is first before we even talk about it, as opposed as it relates to network security. A DMZ often lies along an establishment frontier or boundary between 2 or more military powers or alliances. Probably the most famous DMZ, or infamous in this case, DMZ in the world, would be the one that sits between North Korea and South Korea, right? We know this DMZ right here, and this red line right here, that is pretty much the border between North Korea and South Korea, as you can see, and it's considered a demilitarized zone. So they don't have any kind of military activity that happens there. You can't have any gunfire there, etc., right? And both of these countries agree to that by what the DMZ is. So now, how does this relate to network security, right? Well, a DMZ in computer security is a demilitarized zone, sometimes referred to as a perimeter network or screen subnet. It's a physical or logical subnetwork that contains and exposes an organization's external facing services to an untrusted, usually large network such as the internet. So remember, we said we got the inside network, and then we also got the outside network, right? Well, between the two, we got the DMZ, right? So why would we need a DMZ in our network? We might have a device that is on our network, right? But we still want people on the outside of the network or the internet to be able to access this device. In this case, this email server. Email servers are very common to sit in a DMZ. And the reason why is because we want it accessed by people on the inside of our network as well as the outside of our network. But we don't want people on the outside to access the inside. So what do? We put the DMZ or device in our DMZ. We put our DMZ in between the two. So in this case, the email server, as you can see, allows traffic to flow from the inside of the network to access the mail server, right? And come back into the inside. But we also allow traffic to come in, not necessarily in our network, but into the DMZ, and still access the email server and come back out to them to get whatever they need, right? But people on the outside on the internet as you can see, they cannot access our network, right? Because that's what the firewall is doing. It's blocking this traffic right here, right? Make sure y'all see this red X right here. It's being blocked. So people on the outside can't access the inside of our network. However, they can still access the email server, which is on our, which, quasi, sits on our network. And that's why we call it a DMZ, because it sits between the two inside and outside networks. Here's another DMZ example. We have traffic, people from the inside of the network. They can access the outside of the network, right? So we have people, we have our users. They can still get on Twitch. They can still get, Netflix and stuff like that, right? From the inside of the network, right? And then we still have people on the inside of from the internet. They can get onto our network, sort of, right? They can access our web servers, example.com, because we couldn't think of a better name than this. But they can't access our network, right? So we might have, maybe this interface might have, some kind of ACL to not allow traffic coming from the outside of the network in here. And the same thing is here. We only allow traffic going outbound this way, right? We'll let traffic inside this way, but it will depend. We'll have some rules that'll allow who can access it. But as far as these email servers, we allow people to freely come in and out of our network like this. So now that we've discussed what a firewall is, right? Let's talk about what IPSs are, right? And that's what we were talking about, what we said we were going to discuss in the beginning of the video. An IPS is an intrusion prevention system, also known as an intrusion detection and prevention system, or IDPS, network security appliance that monitors network or system activities for malicious activity. The main functions of intrusion prevention systems are to identify malicious activity, log information about this activity, report it, and attempt to block or stop it. Now, y'all know I get my definitions from Wikipedia. However, I didn't really like this definition. It kind of misconstrues and kind of like confuses you as far as what an IPS and an IDS is. It kind of says, it makes it seem like they're one and the same, but in actuality, they're not. As you can see right here, we have our RPS sits behind our firewall that we just discussed for the past 20 minutes. And then he sits behind our router, right? Router 1 right here, right? So we have our router, we got our firewall, we got our IPS, and we have our signatures. What are signatures? Well, think of signatures as kind of like wanted posters. So remember we discussed the firewall right here, right? So the firewall, he's letting people in and out of the club, right? He remembers, stuff with stateful information, right? But he also has, IPSs mostly. Firewalls can have this as well, but most IPSs have signatures. A signature is basically kind of like the wanted poster. So he remembers, somebody that's on America's Most Wanted or something like that. He has these pictures on his wall. He I remember this dude killed the lady or whatever. So he's not going to let them into the nightclub or whatever the case may be. That's what what a signature is. A signature remembers threats or bad people or bad hackers and stuff like that. Bad virus signatures. That's what signatures are. They basically are, information about things that can threaten our network. That's what a signature is, right? So we have this right here. It's a database of signatures. So we have all of our wanted posters, all of our threats, anything that can, compromise our network security in this database of information called signatures or virus signatures. And the IPS keeps a track of this stuff, right? And it has to keep getting updated because we might have more wanted people, added to the wanted list, right? Or, FBI's most wanted or whatever the case may be. Those lists grow and get updated all the time. So we need to keep our virus signatures or threats updated. That's what the signatures are. Most signatures lie, as you can see right here, on the IPS or intrusion prevention system. What is let's get further into what an IPS is, right? It prevents threats from intruding our systems, right? But let's talk about the difference between, now, as you can see right here, it said IPS and IDPS. Don't get them too confused. This is why I said, y'all know I love Wikipedia, but I didn't really like this definition right here. So let's talk about the difference between IDS and IPS, right? So intrusion detection system monitors and analyzes network traffic for packets and signs of network invasion, right? So we detect bad threats to our network. It detects it, right? You see the firewall or the IPS is kind of similar to the firewall. He sees the, bad people or threats coming into the network and he detects it. So he detects it. That's all he do now. The system then flags known threats and hacking methods. IDS systems detect port scanners, malware, and other violations of system security policies. So he detects, right? That's the key word here, detects. That's all he do, he detects. Intrusion prevention, IPS, notice the difference between the two, right? This one prevents. So IPS systems reside in the same area as a firewall between the internal network and outside internet, which is what we said right here. He sits between the firewall and internet and our local area network, which sits right here, right? So he would be kind of like the border, right? The IPS, right, in this sense, or IDS even. If the IDS system flags something as a threat, the IPS system denies the malicious traffic. So the prevention, the IPS prevention, that's the key word here now, prevention, he don't just detect it and he sees it and remembers it. He actually stops you from coming into the nightclub. So the IDS, he's just gonna be like, oh yeah, I remember you. He might let you in, or he might just be like, he might get his manager like, hey, we got to do something about this dude. Like, he trying to come into the nightclub. That's basically what the IDS does. He detects and that's it. The prevention, he makes sure he stops. Shout out to David Bombal for this analogy right here. He said, if I remember correctly, think of the IDS as like, let's say you got a dog at your house, right? You know, and somebody trying to break into your house. The dog just gonna bark all day long, just like my girlfriend's dog. Just yap, 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 just bark all day long. He ain't gonna do nothing. He's just gonna bark. You know, she had a little min pin that would just bark all day long, right? Whereas the IPS rather, intrusion prevention system, well, he won't just bark. He gonna come at you. He gonna be a German Shepherd that's gonna try to like bite this. He gonna stop you from breaking into the house. That's basically the difference between the two. So, what are the next generation products? The book said, yes, the official cert guide, shout out to them though, it said it's not a marketing term. It gets deeper than that. Okay, whoop-de-doo. It is a marketing term. The next generation product is basically, Cisco is not the only one that has next generation products. You know, Juniper, Palo Alto has next generation products. It's basically, they're firewalls and IPS and IDSs, but they do more than what the traditional IDS and firewall does, right? So remember, we said firewalls check source and destination ports, right? You know, or it also checks source and destination IP addresses. Well, a next generation firewall is going to go deeper than that. It identifies applications matching their static well-known TCP. So he might not just block you by, you know, where you came from, your source IP, and where you're trying to get to, your destination IP. He might be like, oh, you trying to access, you know, Pirate Bay or something like that. Or you know, we've got traffic coming from, you know, some other torrenting system like that. An IPS or next generation product can get deeper than that. It goes inside the packet and does a really deep inspection of the packet to see whether this is going to be a threat or not. That's basically what it is. It gets deeper to, you know, analyzing the packets and stuff like that. It also uses whitelists or signature-based IPS to distinguish between safe applications and unwanted ones. What's a whitelist? A whitelist is the opposite of a blacklist. Blacklist is like the bouncer at the nightclub again. He has this list of people that can't get in. That's the blacklist. The whitelist is obviously people who can come in, who's able to access the network. Or signature, we said what signature is, right? Signature is basically the wanted posters. IPS to distinguish between safe applications and unwanted ones. So we got traffic coming from, you know, some malware or something like that. What we think is malware, and what we consider malware, will be in our virus signatures. We were like, okay, well, stuff coming from this specific URL, we consider that a threat. We're gonna put that in our virus signature. If we see something in that falls in this URL or in this domain or whatever the case may be, if it comes from www.iamathreat.com, we're not going to allow it, right? So we can base, you know, threats off of our URLs. So that's what next generation products do. We have traditional firewalls that can check source and destination IP. We have our inside and outside interfaces and stuff like that. But a next generation firewall will get deeper than that. It'll do a deep packet inspection. That's what next generation products do. I'm sorry for talking y'all ear off. I wanted to make this short. that is all I got for y'all today. That is my YouTube page. That is my Twitter handle if you want to connect with me on a more personal level. In the next video, we are going to get our hands dirty. Either set up a basic firewall, you know, like ASA or something like that. Or if I get my hands on some kind of firepower device, or maybe I'll try to see if I can get it in the D cloud and kind of, you know, demonstrate what a next generation firewall, how it works and how we can set it up. We'll go ahead and do that. But for now, please comment, like, subscribe to the network.